Let's hear from another presenter studying from the Department of Chemistry, Eniko Zsoldos.
When you go to the gas station, how much do you fill up your car? If you only have 20 bucks, maybe that's all you're putting in it. Or maybe you fill it up all the way. Either way, it won't really matter. The car will still get you from point A to B and last about 300,000 kilometers. But for electric vehicles, how much you charge up your battery matters a lot. That can affect whether that battery lasts you 5 years or 20 years. Let's look at 2 examples. Alice charges her car every night at home, making sure she's at 100% in the morning before she leaves for work. Maybe you do the same thing with your phone battery, keeping it near 100%. Alice doesn't know this is making her battery die faster, costing her money and creating a larger carbon footprint to replace that battery sooner. On the other hand, Bob keeps his battery near 50%, only charging it up to 100 when he needs it for a road trip on the weekends. We wanted to test out Alice and Bob's batteries in our lab, so I took some scissors and cut some batteries open at these different states of charges. Now, of course, don't try that at home, because they'll catch on fire, and you don't want your leg to end up like mine. But of course, the really cool thing about these batteries is that the graphite electrode changes colors depending on how much lithium there is in it. So when you see the black graphite turn red and then golden like Alice's, you know it's at a higher state of charge. Next, I put the electrodes into a machine with precise thermometers to measure how much heat they produce. You know when you plug in your phone to charge, it feels hot, right? Most of that heat comes from the electrical wires and resistance in the system. Another part comes from the normal chemical reactions that are charging up the battery, and the rest come from parasitic reactions that are damaging the battery irreversibly. And those are the reactions that I really care about when we predict lifetime, because they are present for Alice and Bob all the time, even when the battery is not charging. We found that Alice's golden electrodes heat up way more than Bob's. So that means keeping your batteries at 100 will damage them the most, and then they're incrementally less reactive at lower states of charge. So there's a trade-off here. A lower percent charge is not a very useful battery, but it will last you many more years. We all know we have to transition to sustainable energy, and that means we need our batteries to last us generations rather than just a couple of years. Just by switching from using our batteries like Alice to Bob, our batteries can last 3 to 4 times as long, and no extra cost. And if we can make one battery last a longer time, that means we need to dig up less critical minerals like lithium from the earth to build up our green energy supply chain. I'll leave you with a final question. When you're charging your phone tonight, are you going to set it up to stop charging before it reaches 100%? Thank you.